Hello and welcome back to the channel. Now in this video we're going to be learning about the Dynamic Host Control Protocol, or DHCP. And DHCP is a service that automatically assigns IP addresses to our devices. It does help make IT guys' lives easier because we don't need to go to every device and manually add an IP address. So currently in PRB Investments infrastructure, all DHCP requests is currently handled by our OPNSense router. But we would like to change this since we would like to centralize a lot of our scopes. And for this video, I've created a new Windows server called DHCP01. However, if you're tight on resources, you can install this role on DC01. Since this is a test environment, and my DHCP server is set up with the following configs. So my time zone is Eastern Standard Time. My remote desktop is enabled. My computer name is DHCP01. My domain is prbinvestments.local. And my IP address is 172.20.20.23 with a /24 subnet. So let's dive in. Now the first thing that we want to do is we want to add another network adapter to our virtual machines. So I will click Edit on my VMware workstation, then Virtual Network Editor, and here I will click on Change Settings, and I will say yes to allow this application to make changes to my computer. And here I will add a new network, and I will select VMnet 11. But you could choose any network that's available to you, or if you prefer to choose another network, you're free to do so. Then I will click OK and we'll wait for VMware to create our new network adapter. And once the adapter has been created, I will change the subnet IP to be 192.168.10.0, and we'll leave the subnet mask as is, which is 255.255.255.0. Then I will uncheck the option to use VMware's local DHCP service. Then after I am done, I will hit apply to save my changes, and then I will click OK. Then I want to assign this new adapter to my OPNSense VM. So I will right click on my OPNSense VM tab, and then I will click on Settings. And here we have our two network adapters, but I want to add a third one. So we'll click on Add, we'll select Network Adapter and click Finish. Next, I will change my network connection for the new network adapter 3 to be our new VMnet 11 network. Then I will save my changes. Now back in our OPNSense VM, I will log in with my root username and password. And the first thing to note here is we see our LAN and WAN adapter assigned to EM0 and EM1, but we don't see the new adapter that we just added. And first I'll hit option 1, then I will say yes to both of these, and indeed we don't see our new network adapter. I'll press Ctrl+C to cancel out of this action, and then I will reboot my OPNSense system. Now, once the system is back up, I will log in once again with my root username and password. And once again, we'll enter 1. And this time we can see our new EM2 interface is now present. So here, I'll just reconfigure my interfaces. So for WAN interface, it will be EM1. For our LAN interface, it will be EM0. And for our OP1 interface, it will be EM2. And then we'll skip the OP2 interface because we don't have any. Then we'll say yes to proceed. And once it's done reconfiguring, we can see our new EM2 interface is now present. However, it doesn't have any IP address or any network information, so we will need to configure this. And I will configure this using the web interface for OPNSense. So I will head over to bclarkpc. And here I will open up a web browser and I will type in the IP address from my OPNSense router, which is https://172.20.20.254, which is the LAN IP address of our OPNSense router. Now, usually when you're logged into the router, you have to use your LAN IP address because by default, your WAN connection will block these connections. Then I will log in with my root username and password. So this is the web interface for our router, and we can configure options for OPNSense that's not available at the console interface. And if you notice that my portal looks a bit different compared to yours, that's because I've performed all of the updates off screen for my OPNSense router. You can do this by going to System, then Firmware, and Updates. And here you can update your system to the latest version. But this isn't required to proceed with the next step. So first, what we need to do is we need to disable our DHCP service on the router. So we'll go into Services, and then ISC, DHCP v4, and then we'll click on LAN, and then we'll uncheck the option that enables DHCP service on the LAN interface. Afterwards, we'll save our changes. And then under Interfaces, we'll click on Op1. And we'll just ensure that this interface is enabled. And then we'll scroll down and we'll configure the IPv4 settings. Basically, we're creating a network for our new interface, and we'll set it to use a static IPv4 address. We won't configure an IPv6 address for this. And then we're going to scroll down, and under IPv4 configuration, we're going to enter the IP address 192.168.10.254. And then our subnet mask will be 24, so this will be equivalent to 255.255.255.0. And then we'll hit the save option. We're going to scroll up and then hit apply changes. And the next set of changes that we need to do is to apply some firewall rules to our new Op1 interface. So under firewall, I will click on rules, and then I will click on LAN to show you that the rules that are configured. So currently our LAN interface is set to forward all traffic to any relevant destination for both IPv4 and IPv6. And if I click on the Op1 interface, currently the only rules we have here are rules that denies all traffic. So we'll add a rule to pass all traffic. And here you can specify the destination, the source, or other configurations that you want if you want a more secure connection. For now, I will leave everything as default, and then I will hit save. And then I will hit apply changes. Next, I will right click on my network icon and click Open Network and Internet Settings. Then I will click Change Adapter Options. We'll right click on Ethernet 0, and then we'll go to Properties. And we'll click on Internet Protocol version 4, and then click on Properties here. And then here I will set the IP address and DNS to obtain their IP addresses automatically. And then I'll click on OK, and then close. Now what we'll do is I'm going to open up our CMD prompt, and I'll type ipconfig. And we can see the IP address we have here is 169.254.168.135. And if you work in IT and you see this IP address, it means that your computer tried to obtain an IP address on your network, but it failed. Anytime you're troubleshooting a computer's network connectivity and you see this IP address, it's called an automatic private IP address, or a PIPA. Your network adapter will automatically assign this IP address to itself using this IP. And when you have this IP assigned, you're not able to communicate with other devices on your network. And for this demo, I've created a new server called DHCP01. But if you choose to, you can install the server role on DC01. And this server currently has the following configuration. The time zone is set to Eastern Standard Time, and the IP address is 172.20.20.23. Remote desktop is enabled. The company name was changed to DHCP01, and we've added it to the PRB investments.local domain. To install the DHCP server role, I will click on Manage, then Add Roles and Features. I'll click Next on the Before You Begin page. Then I'll leave it as role-based or feature-based installation and click Next. We'll leave the DHCP-01 as a server that we want to install the role on and click Next. And for the roles, I will select the DHCP server role and I will add the required features, and then I will click Next. For features, we'll just hit Next because there are no additional features that we need. Next, the DHCP server page just tells us a bit more about the DHCP service, with two things to note. One being that we need a static IP for this server, which we have. And next is we should plan our subnet, scope, and exclusion list first before we install the service. We'll hit Next, and then we'll hit Install. And while the installation is going, I just want to increase the size and change the color of my mouse cursor. So I'll just click on the Start menu, type in mouse, and then I'm just going to change these settings. So I'll change the color first, and then I will change the size of the mouse cursor so that we could see the mouse much easier. And once the installation is completed, I do have a post-install task that I need to complete. But once again, if you mistakenly close this, you can always click on the task option and then complete the DHCP configuration from here. The first page just tells us that we need to create 2 Active Directory security groups, one for DHCP administrators and one for DHCP users. But I'll just click Next here. Then it asks us to specify the credentials to be used to authorize this DHCP server. And I'll leave this as my PRB admin user account because this account has domain admin privilege, so it's able to perform the task that DHCP will need. Then I will click Commit, and once it is done, I will click Close. Then I will click on Tools, then DHCP. And here we'll wait for the MMC to open. And once the MMC is open, I will expand everything. So at the top, we have the DHCP service. If I right-click on this, we can add a server if we need to. So if I had another DHCP server on the network, I can add it here to manage it. Next, we have the option to manage our authorized servers. We currently only have one. And authorized servers are basically servers that have been specifically approved to issue IP addresses in a domain-based network. Then I'll right-click on DHCP 01, and we have a few different options here. First, I can add and remove bindings. Clicking on that will bring up the server bindings properties, and we can see that Ethernet 0 is currently checked as a bind interface. Now what this means is that Ethernet 0 will listen and respond to all DHCP requests within the network that Ethernet 0 is a part of. If this option was not checked, when a client machine requests an IP address, DHCP will ignore this request. If I click on the IPv6 tab, we currently don't have any connected bindings here. In relation to DHCP and IPv6, it operates a bit differently. In some cases, you don't actually need a DHCP service because IPv6 has the capability to assign routable IP addresses to your network. So with that said, I will close this out. Next, we have the unauthorized option, which we know prevents DHCP from acting as a DHCP server. Then we have the backup option, where we can back up all of our active configs. And the default location is in C, Windows, System 32, DHCP, and backup. We can always store this on our network share as well, or in a different location. We can restore from a backup if needed. And below, we have the options to stop, pause, and restart the DHCP service if I'm having issues. View will allow me to change the icons and columns. Delete will delete the server from the DHCP service. And export will export all of the subnets and the DHCP configuration that we have created. Next, if I right-click on IPv4, our first option is to display the statistics, where we can view the start time, offers, and other information related to our DHCP service. New scope is where we can create a new scope for our subnet, and we can create a new multicast scope. A multicast scope allows us to send a single packet from one source to multiple recipients. So things like media streaming, IPTV, and online radio will use this. Configuring failover will allow us to add another DHCP server so we can create some redundancy. And we can also replicate our failover scopes over to another server if we need to. And the other options we have, I will go through later. So for now, let's create our first scope. I will right-click on IPv4 and select New Scope. I'll click Next on the first page that we have. I will name the scope head office-subnet-172.20 and click Next. Of course, you can name your scope anything that you want. And this is where we will configure the range of the IP addresses. So in our network, we currently have a 172.20.20.0/24 network. And this gives us 254 unique IP addresses that we can use within this network. So because PRB Investments is a bit small, we will use a smaller range. So for the start IP address, we will use 172.20.20.10. And for the end IP, we will use 172.20.20.200. So our DHCP server will only hand out IP addresses between the range 172.20.20.10 to 172.20.20.200. And when it comes to IP address assignment, the DHCP server will start from the first IP address, so 172.20.20.10, and then it will hand out IP addresses in sequence. For the subnet length, we'll change this to be at 24. Notice when I change the length, the subnet mask also changes. Basically, the higher the subnet mask is, the less IP addresses will be available within that network. Exclusions are where you can exempt a certain range of IP addresses to not be given out. Currently in our network, DC01 is assigned to 172.20.20.20 and DC02 is assigned to 172.20.20.21 and FS-01 is assigned 172.20.20.22 and DHCP01 is assigned 172.20.20.23. Now if we continue with this arrangement, the next server will have the IP address 172.20.20.24 and so on. Now we can exclude these IP addresses, so DHCP does not give it out to another device. So for the start IP, we'll do 172.20.20.20. And the end IP, we're going to use 172.20.20.80. And we'll click Add. And we can add another range as well. And we'll add 172.20.20.150 and 172.20.20.200. And then we'll click Add again. Now one thing to know is you can only specify exclusion between the range you've chosen. So if I try to exclude the range 172.20.20.1 to 172.20.20.9, this won't work because this range is not within the 172.20.20.10 to 172.20.20.200 range. That was specified for this subnet. We'll click OK and then we'll click Next here again. For the lease duration, we'll leave this as 8 days and click Next. For the DHCP options, we'll leave this to configure these options now. For the router, the default gateway, this will be the IP address of our OPNSense router on the subnet. So it will be 172.20.20.254 and we'll enter that and then we'll hit Add and then we'll hit Next. For domain name and DNS servers, notice this was pre-filled in for us. Because we're in an Active Directory domain, DHCP01 will grab this information from our domain controllers. We'll click on Next. For Win servers, we'll leave this blank, since Wins is a legacy system that is no longer used in modern systems. Then we'll choose Yes. I want to activate this scope now. Click Next and then Finish. Then I'll click on the scope we've just created. The address pool will show us the range that we've configured. We see the initial range is 172.20.20.10 to 172.20.20.200. And the description reads address range for distribution. And the to range below that reads IP address excluded from distribution. Address list will show us the current active DHCP lease. We currently don't have any. Reservation is where we can reserve a specific IP address for certain devices. For example, if you had printers or other devices within your network that received an IP address from DHCP, we can reserve these IP addresses, so our DHCP server will only assign these IP addresses to those specific devices. Scope options is where we can configure certain parameters that gets assigned. Currently, DHCP will assign the default gateway, the IP address, and the DNS servers, as well as the DNS domain name. But we can choose other settings as well. I'll right-click on Scope Options. Then I will click on Configure Options. And we can see all of the available options that we can use. For example, if you have a phone system that you manage, sometimes your vendor will request a boot file be delivered through the DHCP offer. We can enable a legacy option called Time Servers. If we're working with older systems that needs this configured, I can check the box for time server. I can add DC01 hostname here. Then I can click on Resolve, and you can see that it pre-fills in the IP address for us, and we can hit Add. But just so you know, time servers are no longer in use in modern computers. Use NTP if you need to control your time through a server. And then I'll click on OK, and we can see that we've added the time server here to our options. Afterwards, I'll head over to bclarkpc, and then in CMD, we'll type ipconfig space /renew. And we can see that we've received a valid IP address. Next, I'll type ipconfig space /all. And then we'll scroll down, and we can see we have a line for the DHCP server, and we can see that the IP address is 172.20.20.23, which tells us that our client machine received the IP address from DHCP 01. Then I'll head back over to DHCP 01, and I'll refresh the address list, and we can see that bclarkpc has been assigned an IP address from DHCP 01. And I can also right-click on the machine, and I can add it to reservations. We get a message telling us that it has been successfully added, and if I click on the reservation, I can see the options that was assigned to it. Now, creating a DHCP server to assign IP addresses in a single network is kind of easy, just based on how networking is designed. Devices within the same network as a DHCP server will always obtain an IP address with little to no issues. But what if your device is on a different network? So let's test this out. I will head over to RBEC and I'll sign in with my PRB admin user account. So first we'll open up CMD. And we'll type ipconfig /all. First thing to note here is that we don't see a line for the DHCP server because this IP address was manually assigned by me and not through DHCP. So I will right click on my network icon, then I will click on Open Network and Internet Sharing Settings, then I will change adapter options. I'll go to the properties of my Ethernet 0 adapter, and I will set the IP address and the DNS to obtain an IP address automatically. And if you're thinking, wait, if you set this to obtain IP address automatically, won't it reach out to the DHCP 01 and grab an IP address? And yes, it will. It will obtain an IP address from the 172.20.20.0 network. But that's okay because of the changes we are going to make. Next, what I'll do is I'll right click on the RBEC VM, and I'll go into Settings. And then we'll change the network adapter from custom VMnet 10 to VMnet 11. Then, back in RBEC, I'll clear my CMD window and type ipconfig /all. And you can see that we didn't obtain an IP address. Because remember, the network 192.168.10.0 does not currently have a scope defined for it. So let's change that. Let's head back over to DHCP 01. Then I'll right click on IPv4 and I'll create a new scope. I will name it remote-office-192.1.0 and then click Next. The start IP range will be 192.168.10.10 and the end IP range will be 192.168.10.100. We'll leave the length as 24 and the subnet mask as 255.255.255.0 and click Next. We will not add an exclusion to this range, so we'll click Next. We'll leave the lease duration as default and click Next. I'll say yes to configure these options now. And for the router IP, what do you think we should use here? Just take a minute to guess. And if you guess 172.20.20.254, you are absolutely incorrect. Remember, the default gateway must be within the 192.168.1.0 network. In this case, it will be 192.168.10.254, which was the IP address we assigned to the UP1 interface on our OPNSense router. We'll enter that IP address in here, and then we'll click Add. We'll click Next, and the domain name and DNS server has been added. And if you're thinking, wait, so the default gateway must be in the same network as the DHCP scope, but the DNS server can be in different networks? Yes, that is correct, because your DNS server can be in another network as long as you have access to them. Some people use the Google DNS for the DNS servers, which is 8.8.8.8 and 8.8.4.4. And usually you're not in the 8.8 network, right? Your IP address is probably within the 192.168.1.0 or the 10.0.0.0 network. So a different network. But as long as you can reach those DNS servers, you can resolve the DNS names to IP address. And the same goes here. 172.20.20.0 and 192.168.10.0 both exist on the same router, so we know the router will forward the traffic wherever it needs to go. But we'll click next here, and we'll click next for the Win server as well. And lastly, we'll click yes to activate these scopes now, and then I'll click on finish. And now our new scope is active, so this should work, right? We'll head back over to RBAC PC and let's try it. And let's see what happens. I'll do an ipconfig /renew. And we get an error message that says that it cannot contact the DHCP server. And if I do an ipconfig, the IP address that we get is the 169 IP, which means this PC is not able to reach the DHCP server. Now, this is actually expected because of how networks and DHCP works. You see, when a computer first boots up, while it's powering on and loading the programs, it will check to see if it has an IP address. And if it does have an IP address, then no configuration is required. Now, for a computer that does not have an IP address, what it's going to do is send out what we call a broadcast message to the entire network. So all devices within this network is going to get this broadcast message. The broadcast address is 255.255.255.255, and the message will say, hey, can you give me an IP address? And this message is called a DHCP discover message. When devices receive this message, depending on what they are and how they are configured, they will respond differently. For DC01, DC02, and FS01, these servers will just ignore the request because they are not configured to respond to this kind of request. DHCP01 will receive the message because we installed the DHCP server role on it and will respond, hey, yes, I can give you an IP address. OPNSense is very important because OPNSense will just drop this packet. Routers are designed to always discard broadcast messages like DHCP discover messages. For DHCP01, this is the process of obtaining an IP address. First, we have the DHCP discover. This is a broadcast message that gets sent out to all devices on the network. The IP address used here is 255.255.255.255, and the message is going to read, hi, can I have an IP address? And what is important here is that this message will include the MAC address of RBAC-PC. A MAC address is a physical hardware identifier that all network devices have. And DHCP01, because it's a DHCP server, it will respond with, yes, I am a DHCP server, and I do have an available IP address for you. Then DHCP01 will send an IP address with the subnet mask and the default gateway. And what is also important here is DHCP01 will send this back as a broadcast address. So that same 255.255.255.255, because remember, RBAC-PC still does not have an IP address to use. DHCP01 is given it one, but it's not yet assigned. So DHCP01 does not know how to directly contact RBAC-PC. So DHCP01 will send this back as a broadcast message, but it will include the MAC address of RBAC-PC, so there's no confusion as to who responds to this message. And once RBAC-PC has the reply, it will send a DHCP request to say, yes, I would like to use this IP address. And lastly, DHCP01 will acknowledge and reply. And RBAC-PC will now have an IP address assigned from the DHCP01, and it will have one that is able to communicate on the network. Now, this seems easy enough, right? But it didn't work for RBAC-PC and the new subnet that we created. And this is why. So every network is its own broadcast domain, meaning that the broadcast message, like the DHCP discover message, will only be delivered to computers within that network. So if we take a look at our network, OPNSense has two broadcast domains, the 172.20.20.0 network and the 192.168.10.0 network. So devices that's on the 172.20.20.0 network can only send broadcast messages to those devices on the network. And just so you're not confused, broadcast messages comes in the form of 255.255.255.255. Other devices on this network will receive it, but the routers will discard it. And the same idea with the 192.168.10.0 network. If a device within this network sends out a DHCP message, all devices within this network will get it. So we see that there is no device on this network. So when RBAC PC sends out a DHCP discover message and it goes to the UP1 interface on OPNSense, it will get discarded. Now, there are a few ways to fix this. One will be to add another network interface to DHCP 01 with the same VNet 11 network, but that's the easy way out. And if you have a physical system, this might not be feasible to do this. You can also enable the DHCP service on the UP1 interface, which will work, but then there's no point in having a separate DHCP server if your scopes are on different systems. And the other method I will show you is how to set up a DHCP relay. And this is how a DHCP relay works. First, RBAC PC will send out a broadcast message. Then OPNSense will receive it. But since we enabled the DHCP relay agent on OPNSense, instead of discarding the DHCP discover request, it will forward it to the relevant server. In this case, that is DHCP 01. And this process is mostly the same. OPNSense will reach out to DHCP 01, and it will convert the IP address from a broadcast address to a unicast address. The broadcast address is 255.255.255.255, and the unicast address in this situation is going to be the IP address of DHCP 01, which is 172.20.20.23. Because OPNSense is configured to know who is the DHCP server. DHCP 01 will respond back with an IP address to OPNSense. OPNSense will forward that IP address to RBAC PC, and RBAC PC will accept the IP address and will respond to OPNSense to let it know that it will accept the IP address. OPNSense will then respond back to DHCP 01 to let it know that the client will use the IP address, and DHCP 01 will send its acknowledgement to signify the end of the process. Alright, so we got our theory down. So let's configure this. Back in bClark PC, I will open a web browser and I will navigate to https://172.20.20.254. And here I will log into my OPNSense router. And once I'm in, I will go to Services, then DHC Relay, and then Configuration. For the destination, I will click on the plus icon. The name will be DHCP 01, and the server will be the IP address of DHCP 01, which is 172.20.20.23. And then we'll hit Save. Next, we'll click on the plus icon on Relay, and then this is where I will enable the relay on the UP1 interface. And I will also check the box for the agent information, and I will hit Save. And then I will add another relay, and this time I will add it for the LAN interface. And really, for this configuration, you just need it for the UP1 interface for this to work, but I'll just add a LAN 1 interface just in case, because networking can be a bit finicky on virtual machines. But once I'm done with that, I will hit Apply. And then I will head over to DHCP 01, and here I will right click on DHCP 01, and I will choose to restart the DHCP service. Next, I will expand IPv4, and then I will right click on the head office subnet and then select Display Statistics. And we see for in use, we have 2. Now don't get too excited, because if I go to address leases on the 172.20.20 network, we will see that the RBAC PC is in here, which is incorrect. Now RBAC PC is in here because back when we were changing it from static assignment to automatic assignment, there was a period before I flipped the network adapter from VMnet 10 to VMnet 11, and during that period it obtained an IP address. So that's why it's here. So we will delete this. and then I will head back over to RBAC PC, and in CMD, I will do an ipconfig/all, and we see success. The IP address we have is 192.168.10.10, and the DHCP server is 172.20.20.23. So this means that our configuration actually worked. Alright, so that is it for the video. Now, if you are able to follow along and you are able to properly get everything working, then great job. I know we covered a lot in here, and especially with the DHCP relay, it can get a bit complex. So I hope my explanation was enough to help you understand these concepts. If not, I've left a few resources in the video description below that might explain it better than I can. And here's a bit of a recap as to what we've learned in this video. First, the DHCP service is used to automatically assign IP addresses to devices on a network. Devices within the same network are inside of a broadcast domain. A device without an IP address will send out a DHCP discover message to all devices on the network. Devices that are not configured with the DHCP service will ignore this message. A DHCP server will respond to DHCP discover requests and will send an IP address offer to the device. Routers by default will discard broadcast messages. They do not forward any address that is 255.255.255.255. Routers can forward the DHCP discover message to another network if it has the DHCP relay enabled. And lastly, the DHCP relay service is not unique to OPNSense. Any layer 3 device will have this, so things like routers, layer 3 switches, or firewalls will have a DHCP relay option. And lastly, remember DORA. So discover is where a client will send out a DHCP discover message if it needs an IP. Offer is when the DHCP server will respond with an available IP address. Request is when the client will request the available IP address. And acknowledge is when the DHCP server will acknowledge the client request, and acknowledgement is usually the end of the DHCP process. So I hope you learned a lot in this video. If you have any questions, comments, or concerns, please leave it below, and I will see you in the next video.